Hello everyone. In this video we'll be solving buy and sell stock 2. In this question what we have to do is we have to buy stocks on one day and we will set it in future. We can buy at least one stock at a time. There cannot be two stocks. We can buy two stocks at a time. First we have to sell one stock, then we can buy the other stock. So let me just explain it with an example. If I buy one stock on day 2, I can sell it on day 3 and on the day with the value of stock is 6, and the profit will be the current day minus the previous day's price. So we have to maximize our profit, and we can do it anytime possible. So we will just try recursion over here, because with the help of recursion we can try all possible ways, and we'll just decrease the complexity to further with the help of memoization and further with tabulation. So let's get started. So in this question what we can do is we'll just try with the help of recursion. So I'll just create a recursion type function. We have variable by vector of int prices, int index, and int buy. With the help of buy variable, we can decide whether we should buy the stock today or not. And just call just call the help function from here. We just start prices index will start from 0 and buy it. The value of buy equals to 1 means we can buy it on the current day, and if it's 0 we can sell today also. So if buy is 1, that means we can buy it today. We'll just return max of, if we can sell it today, we can buy the stock today. So we'll just remove prices of I in current index from our profit, because we have just bought and the price will get reduced. So we'll just call the function index plus 1, and we pass 0 over 0 variable 0 value in the buy variable, because now we can sell it on the other day, upcoming days. If not, we will just call help prices comma index plus 1, and we can still buy on the other days. And if value is equal to 0, then we can sell it today, and we'll just add prices of index to our value, because we have just sell the stock, and the current amount will be our profit. Then we'll just prices of index 1, and we'll just pass buy value plus 1, because now we can buy another stock. And if we do not sell it today, we'll just pass index plus 1, and we can still sell it on the other day. And the base case would be if our index is greater than equal to prices is equals to n prices dot size traverse the full array. So now the profit will be 0, or the means remove if we can buy the stock, and if we have bought the stocks in the previous days, and we cross the value of the index. If in the index crosses the If the index crosses the array, that means we can either sell it or sell it. So that means the profit will be 0. So we just returned 0, and we'll just run the current. Okay, this is running, but this code will give us time limited existed, because the complexity of this code is big of exponential, which is not which is not accepted, and which is very high. And the space complexity is big of n, because we are just traversing the whole array, and the stack is of size big of n. So to convert it into memorization, we will just create a DP matrix table, DP table of size n cross 2, because there are two variables changing, index and buy. The buy value is from 0 to 1, two values, and the index is 0 to n minus 1. So n into 2. We'll just create a 2D vector of n comma vector of int 2 comma -1. We will just pass tp over here. We'll just pass tp over here percent. If tp of index and by is current calculated previously, so we just don't need to recalculate it. We just return tp of index comma by, and if tp of index comma by, and we just store the returned value from the function calls, so it makes our work easier. And we'll just pass tp here, tp here, and we'll just run it. Oh, sorry, we forgot to mention what is the value of n. Int n equals to license dot size. Just run it. This is coming correct answer. So the time complexity of the solution is big of n into 2, and the space complexity is big of n into 2 plus big of n. Big of n is the stack size, so we just need to omit the stack size from the our space complexity. So what we will do, we will just convert this solution into tabulation form. So for need, we will just write, we have to write for loops. So I will just create a vector tp. I will just increase the size of n by 1, because our base condition says that if index is equals to n, dp of n is only accessible if the size is n plus 1. So we'll just create a greater size, 1 greater 1 size greater, and we'll just initialize all the vector with 0. We don't need to initialize the base condition because the tp table is already initialized with all zeros, and the base condition is also says that initialize the base condition with 0, so we don't need to initialize it. Our memoization approach was from 0 to n, which is 0 to n. So our tabulation will be from n minus 1 to 0. So I will just write int idx equals to n minus 1, idx greater than idx is greater than equals to 0, idx minus minus, and the value of by is 0 to by is equals to 1 by plus plus, and we'll just copy here what we have written in the help function. So if y is 1, what I will write dp, what I will write here is dp of index comma by is equals to max of minus prices of index plus help. In place of help function, we'll just write dp of index plus 1 and 0 comma dp of index plus 1. Okay, else we'll just write dp of index equals to by, we'll just write max of prices of index plus dp of index plus 1, and we'll just write here 1 and dp of index plus 1 0. Okay, and after that we'll just return dp of 0 comma, just run it. Why this is not working? Okay. So as you can see, let me just rerun it. Let me just submit it. So as you can see, it is accepted. The time complexity of this solution is big of n into 2. The space complexity is also big of n into 2. Thank you for watching.